We are here with Will from Virginia Tech, and he's going to present to Miss Gibson's 5th grade class.
Like she said, my name's Will. I'm a student here at Virginia Tech, majoring in mechanical engineering. But I'm here to talk to you today about my senior design team, which is Bolt. So I'll show you. You all see the bike over there? So this is our motorcycle. We've been working on this bike in particular for about a year and a half now. The whole goal of our design team is to turn a traditional internal combustion engine powered motorcycle, like one that runs on gasoline, into a 100% electricity powered motorcycle. So you may have seen in the news recently, or in the past couple of months, people talking about electric vehicles. And this is a new technology that's come online in the past 5 or 6 years or so. And one of the advantages is it doesn't use any fossil fuels, gasoline, things like that. You can plug your vehicle in to a wall outlet at home. It charges up, and then you can drive it around quietly and cleanly. So our design team specifically focuses on motorcycles, turning a high-performance racing motorcycle that's gas-powered into one that is powered by electricity. But we want to prove that an electric bike can be as powerful and as fast as a gas-powered one. Like I said before, we've been working on this for about a year and a half now. This is the 4th iteration of the Bolt motorcycle. Right now, it's currently under production, but we're super close to doing the final assembly and getting it on the racetrack. It can go over 180 miles per hour. It's got a power output of 200 horsepower, which is a lot more than your standard, like the car that your parents drive around, which is pretty cool. This is one of our battery packs. So in here, we've got a bunch of different individual battery cells, and then we put them together, and we put this big tray into our motorcycle. All of our batteries go down in here, and they power this motor right here. So this motor, inside of here, there's a lot of copper wiring that's wound up into big coils. And then when the electricity from the batteries gets put in to here, it spins this output shaft right here. And so when that spins, we have a sprocket that goes on here. Here it is. So sprocket kind of looks like this. This is a prototype. So that goes on right there. So that's the powertrain subsystem. That's the system that I'm mostly responsible for. We also focus on safety. We have a lot of experience in the 8 years that we've been working, that we've been here in the Wear Lab, and we know from firsthand experience how important it is to keep our bikes safe. And so there's a lot of different things on here that we can use to run the bike and make sure that it's running safely. We've got a circuit board. So it's kind of like the one that's in your computer. It processes the data that we get off the bike, so we can monitor the temperature of the batteries.
Why is it called Bolt?
So Bolt is actually an acronym It stands for Battery Operated Land Transport. But it's also cool because, you know, like a lightning bolt, that's electricity, and bolt, electricity powered. So it's kind of a combination of things. So the Aware Lab is one of the main mechanical engineering sponsored design labs on campus. So it's located right in the heart of the academic side of campus, and it houses a bunch of different design teams that all have different, you know, goals and projects. But we're mostly all mechanical engineers, and you know, trying to you know, solve some problem. Oh, here's a cool one. So there's a team here that builds a canoe out of concrete. So you'd think concrete, that shouldn't float, right? But they use engineering to design a concrete mold and make a canoe out of it, and it floats, and they race it and stuff, which is pretty cool. Well, the bikes keep on getting faster the more they're made. That's a good question. So we're hoping that, you know, as the battery technology continues to get better, we'll be able to get more power out of those and use better motors and just overall get faster. So Bolt 4 actually is faster than its the previous bike we made, Bolt 3. Basically, we changed the way that the battery pack is set up in such a way that we could spin the motor faster, and we improved we went from going like 120 miles per hour on the track to 150 up to 180 miles an hour. How many motorcycles do you make per year? So that's an interesting question. So Bolt 4 was originally designed and built in a year, but there were some complications during testing, and so the development has unfortunately been dragged on a little bit. And due to COVID and all that, we had to stop all of our work in the Aware Lab last semester. And so we're just now like starting to wrap up the assembly process. We're hoping to have it running by early November, actually. How fast can they go so far? So right now, the bike can go 0 miles an hour because it's not assembled yet. But once we get it onto the track and testing it, we're hoping that we can easily break that 150 mile per hour mark. So like that's about twice as fast you would want to go on like Interstate 81 or any big highway. Can it go faster than Lamborghini? I don't know. I hear Lamborghinis are pretty fast, so that might be out of the question, unfortunately.
Where did you get this idea from?
Back when the design team started back in 2012, electric vehicles weren't really a thing yet. There were a few on the market, but I guess the purpose of the design team hasn't changed since then. It's always been to, you know, show that, you know, gas engine powered vehicles, you know, have their limits, and we wanted to show that you know, using technology to, you know, implement electric systems on vehicles can be a valid replacement for gas powered engines.
Thank you for all of your time, Will, and representing Bolt, and thank you for attending and all your great questions, Miss Gibson's class.